Thank you. Good evening to you. My name is Anand, and I'm a co-founder of a small company at the moment, which is AINAP. Also, I'm a data science and engineering lead at AINAP. And today I want to talk about something we all use, but rarely question. That is the core of everything what we are doing in AI, machine learning, deep learning, that is data pipelines. So we have spent years optimizing the models, but in production, the AI system don't usually fail because of models. They fail because of the pipelines break. So the question is, what if the pipeline could monitor, reason, and fix themselves? That's what I mean by agents that monitor the pipeline. Before we go further, if we think about the chronology of machine learning, deep learning, and AI, starting from statistics going all the way to AI, the core, again, like I say, it starts with data pipeline. But what about AI in data pipeline and how? So I'll cover those aspects in the future slides. So in real world system, failure don't announce themselves. Data drift silently, schema changes upstreams, job fails halfway, signal arrives late. And most of the time, we detect these issues after the damage is done. So despite all our machine learning sophistications, pipelines are still reactive. Traditional pipelines are great in moving data, but they don't understand what that data means or whether something is wrong. They don't ask questions like, is this anomaly expected? Should I stop the pipeline? Is the data trustworthy? So every failure becomes a human problem. So what changes? We move from pipelines to autonomous system. Instead of just running jobs, we introduce agents that can observe, reason, and act. Now the system doesn't just execute, it starts taking the responsibility of its own behavior. Let's make this real. In typical modern stack, ingestion, processing, and output, we insert an agent layer. The observability agent continuously monitors distribution, failure, latency. The reasoning agent tries to understand why something went wrong, drift, schema issue, upstream failure. And the action agent decides what to do. Retry, reroute, switch models, or escalate. This is how pipeline moves from reactive to adaptive. If you see the example in credit systems, if feature distribution drift, agent can switch model and flag confidence. In lead scoring, if enrichment data is missing, pipeline can reroute and use fallback signals. In IoT or health system, anomalies can trigger recalibration automatically. So instead of breaking, the system adapts. We are moving towards a world where AI systems don't just produce output, they actively protect their own integrity. AI monitoring AI. So pipeline healing themselves, system continuously optimizing. This is the shift from execution to intelligence to autonomy. So in the future, the best AI system won't just predict outcomes, they will protect themselves. And before I thank you, I would like to deliver something more interesting here. if you want to implement this actual system, this is the system architecture to implement that system in real businesses. This is the system architecture to implement that system in real businesses. And at the end, thank you very much. This is me. These are the 3 books authored by me, and the last 2 were bestsellers last year in 2020. One was 2024, another one was in 2025. And the first one is quite basic. So it's like a structure module for someone who is just entering this profession of data science. They can start from Python, going from machine learning to generative AI, and the third book is helping them prepare for any interviews, starting from data engineering to AI. So, last 2 were the ones I was mentioning as the last year. Thank you very much.
Can you show the architecture diagram again?
Yeah, sure.
Thank you.
Thank you.
Thank you so much for this great presentation.